Hello and welcome to all 9th class students for today's science class. In the previous year, we have studied about synthetic material, metals and non-metals, acids and bases, and so on. All these are called matter in science. Today, we will learn something more about matter and is there any general or common property that lies with all the matter and so on. What is matter? The food we eat, the air we breathe, the clothes we wear, the water that we drink, all these are matter. Now, some questions arises. Why the hot food prepared in the kitchen reaches our nose even though we are at the drawing room? If the dosa or pizza is being prepared in the kitchen, we will smell that, we will get the smell sitting in the drawing room. But same thing, we have to smell the cold food, it won't come to us. We have to go there for getting the smell of it. Why the ice in the Simla do not melt in a day? What is the reason for that? And why a diver cut through the water when he dives in water, but he could not able to do the same thing in a rock or a stone? For all such questions, we will find answer in this chapter, matter in our surroundings. So, let us try to know about matter in our surroundings. Is anything? So matter is anything which occupies space and has got mass. So two conditions. One is it has to occupy space and it should have mass. Example: air, rice, water, chair, etc. Air, even though we cannot able to see, it occupies the space and it has got mass. Therefore, it can be called as matter. So, there are non-examples. Examples and non-examples make the concept clear, which are not called as matter. So, they are feelings like love, smell. Feeling doesn't occupy space or it has no mass. Therefore, feeling of love, hatredness or smell is not an example, not a matter. Now let us try to classify what are the different ways the matter can be classified. Let us try to see about that. Earlier philosophers of India and the Greek were of the opinion that matter is made up of basically 5 things: Prithvi, Aap, Teja, Vayu, Rakash. That means it is made up of air, earth, fire, sky and water. They are called Panchatattva. But is it so? Now we have come to know about exactly the nature of the matter because of scientific method we have adopted. Now we know about what is the composition of the matter very clearly. And today we are going to know more about such things. On the basis of chemical composition of matter, it is classified as pure and mixture. So anything that you take in this world is either a pure substance or a mixture of some pure substances. So this is chemical classification, and based on the physical properties, we can able to classify the matter as solid, liquid and gas. So physical nature. What is the physical nature of matter? So physical nature, or what is common property between all the matter is made up of tiny particles. Every matter, if you go on cutting into smaller and smaller pieces, ultimately you are going to get the smallest piece, that is the particle, and every matter is a particle basically, and particles have interparticle force of attraction, therefore it looks like one. Matter is not a continuous one. A log of wood, it is not a continuous one. It is also made up of small and smaller particles by which it is made up of. And these particles of the matter have space between them. The matter, particles of the matter have got spaces between them. And particles of matter are in continuous motion. They are moving. Even the solid particles also have a kind of motion that is called vibratory motion. And particles of matter attract each other. The extent of attraction may be different, but particles of the matter attract each other. Let us try to know about each of this property through some activities. Take some water in a beaker. Take some water in a beaker. This can be done even in the home. Take some water in the beaker and add a teaspoonful of sugar. And then you stir that, and what do you find is sugar disappear from it. Does it really disappear? No, because if you taste the water, it is still sweet. That means sugar is present. When it was in a solid also, it was giving sweet taste, and whenever it was there in this state also, it is giving the same taste. That means sugar is present. It is called aqueous state or solution state. Now in this solution, where these particles of sugar are, they are occupying the space between the water molecules. Probably there is space between the water molecules at which the sugars are present. When they are segregated into smaller and smaller tiny particles, we cannot able to see them at all. Therefore, sugar when it is dissolved, we do not see that particle at all. So this process is called as a dissolution, and we say that sugar is dissolved. Sugar is, in this particular solution, sugar is segregated into smaller and smaller tiny particles, and the smallest particles that we cannot see at all. Now coming to particles are very tiny. How much tiny they are, we cannot able to see at all, is the one thing that I have told you. But let us try to know more about what is how much they small they are. In a 100 ml of beaker, let us dissolve some potassium permanganate solution. Let us dissolve some potassium permanganate solution. And in successive beakers, let us take again 100 ml of water. From each case, now 100 ml of potassium permanganate solution, 10 ml of this is being taken and poured into that. So color will fade, but color is still there. Now this 10 ml of this solution is again poured to another beaker containing water. So again the particles are still there, therefore it is giving pink color. Now if you go on doing like this, you do not find that particles are not present at all. That means the color do not fade 100%. That means particles are very, very, very small. They are present even at this stage. So they are very, very, very small. This particle size is measured in nanometers. 1 nanometer is 10 to the power minus 9 meter. 10 to the power minus 9 meter, and we find the particles of that size 10 to the power minus 9 meter in this solution. Now the particles of matter have space between them. How to understand this? So from this activity you can able to know whether the particles have space between them or not. As I told you, take a beaker and add sugar. The sugar is getting dissolved after stirring, and we find that sugar is disappear. It is not a disappearance of sugar. The sugar is segregated into the particles, and as we cannot see the particle at all, these particles are present in the spaces, and therefore these are the particles of sugar which are very, very, very small, and the space between the water molecules is giving rise to such kind of dissolution process. Space is there with the water molecules, therefore sugar can occupy. So this is how the dissolution occurs. Now these particles of the matter are continuous motion. Now if you take a liquid water, the particles are found to be moving if there is some leaf or a floating material is being there. So you can find that it is, even though it is kept undisturbed way, it is moving. But the particles of liquid are having translatory motion. They can move from one place to another. And gases also have translatory motion. The particles can move from one place to the other. But solids, in case of solids, the motion is vibratory motion. They can vibrate from the mean position, but they also have the motion. So particles of the matter are in continuous motion. Because of this, the hot substance which is present, it will diffuse faster and reaches your nose. Therefore you can get the smell of the hot dosa prepared from a distance. You will get the smell of it, and also it shows that particles of the matter are in continuous motion. Okay, so diffusion is intermixing of particles on its own. So this diffusion occurs in the gaseous state faster. Therefore, smell of incense stick, agarbatti, kept away, you will get the smell of it at distance. So these are all telling you that these are the particles are in continuous motion. This is not because of wind, but it is because of the nature of the matter. Particles are in continuous motion. Now coming to the particles of matter attract each other. How much they are attracting each other? What is the force of attraction between them? Let us try to know. So here is the picture which will show you how the particle intrinsic view of solid, liquid and gas. In a solid, all particles are well arranged and there is less space between them. But particles of liquid, there is space between them. And particles of gas, if it is a container, so they are rarely present. So particles of matter are present like this, and therefore particles of solid are having more attraction power, and then that of the liquid and then that of the gases. So particles of solids have got greater attraction force. Because of this, a person cannot dive on solid, but he can dive in water and cut through the water because the force of attraction is weak. And we are moving in atmospheric air very freely. It is because the particles of gases do not, the force between the particles of gases is so weak that we don't feel that we are cutting the force of attraction and moving. We can freely move our hand in air. We can freely move our hand in the air, but to do the same thing in water, we need some energy. But we cannot do it at all in case of solid particles. This shows that the attraction among the particles of solid is greater than that of the particles of the liquid, and attraction between the particles of liquid is more than attraction between the particles of gases. Now, there are three different physical physical method of classification of matter. So they are solids, liquids and gases. So these are the physical classification. Based on physical property, we can able to classify. Can you name a substance which exists in all the three forms in the room temperature? So this is water. You can see ice, water and also moisture in room temperature. Ice also can be seen, or it can be easily formed. Of course, it can be done in 0 degrees Celsius, but it can be seen in the atmosphere in the day-to-day life. So solid, liquid, gas are the three physical states of matter. Let us try to know more about these solids, liquids and gases. So solids, liquids and gases, how you can able to distinguish them and what are the properties of them? Solids, if there is a vessel and if you try to keep the vessel, a solid in it, it will retain its shape. It won't change its shape according to the shape of the vessel. But if it is a liquid, it won't resume its shape, but it will occupy the shape of the container. So it will occupy the shape of the container, even the gas also occupy. Here another distinguishing character is liquid is at the bottom, but the gases will occupy whole of the container. Therefore, solids are called as rigids. Solids have fixed shape and they have fixed shape, they hold the shape, but they have no fixed shape. Liquids attain the shape of the container and they have fixed volume, but the gases do not have the fixed shape or they have no fixed volume. So if the 1 liter gas you pour it into the 2 liter vessel, it will occupy whole of the 2 liter and its volume will become 2 liter. Therefore it has no fixed volume. Okay. Now let us know more about the property of the solid. A substance is said to be solid. It possesses a definite volume and definite shape. This is the definition of solid. Sugar, rock, table, gold and iron, all these are solids. Right? They have a fixed shape. Right? In solids, the constituent particles are held very closely to each other and in orderly way, and there is no much freedom of movement. So that is, translatory motion is not there in case of solid. Now in case of liquid, liquids possesses definite volume and definite shape. They possesses definite volume but no definite shape, and to take up the shape of the vessel in which they are present. Okay. Example is water, milk, petrol, all this, oil, mercury, alcohol is also. Mercury is a heavy liquid. It is a metal in a liquid form. Okay. Now. Okay. Okay. So examples are water, milk, petrol, oil. All these are liquids. Now let us see what are the other properties of the liquid. In liquid, particles are close to each other, but they can move around. So this is the property. They are close to each other, but they can move around. This is called a translatory motion. From one place to the other, they can move. Now let us see what is meant by gas. So gases are the substances which are neither have definite shape or definite volume. So such substances are called gases. Hydrogen, oxygen, nitrogen, carbon dioxide, all these are gases. Okay. So they are stored with the cap. So the gaseous matter in the particle are far apart as compared to those in solids and liquids. Now let us see the intrinsic view of that. Solids have definite shape because of the particle arrangement is like this, and the space between the particle is minimum. The space between the particle space is minimum, and the force of attraction between them is maximum, and the movement of the particle is minimum, and the movement is called vibratory motion, and they are least compressible. They are least compressible because there is no space between them at all, and the rate of diffusion is least. Rate of diffusion is intermixing. Solid do not go for mixing with other substances. Now coming to the gaseous state. Now gases have no definite shape and fixed volume. Gases occupy the whole space. And the space between the particle is maximum, and the force of attraction between the particle is minimum, and the movement of particle is maximum, and they are most compressible. The gas cylinder that is being used in your kitchen, consisting of the gas which can be spread out into the whole big room like this. That means it is compressed to greater extent, it will be in the liquid form. Let us try to know about liquefaction of gases in that. Then, okay, we find the intrinsic view of the solid liquid gas in this way. This is the gas particles, this is the particles of the liquid, and this is the particles of solid. So this is how it looks like when it comes intrinsic view of the particles, right? Now, change of state. Is it possible to change one physical state into another physical state? A solid can be converted into liquid. Is it possible? Then what are the conditions of that? So let us try to know about the change of state. Solid state can be converted into liquid state by heating, and liquid state can be converted into gaseous state by heating. Again, if you want to do the reverse process, gaseous state, if you want to condense into liquid, then you have to cool. Again, liquid state into solid, then you have to cool. So this is the way interconversion of the state is possible. Now, remember that solid state, particles are closed. When you heat it, so the particles get separated. Particles have got greater freedom to move. Their interparticle force of attraction weakens. Again, further you heat, then the particles are far apart and resembles the gaseous structure, that is moisture, or that is the steam. If it is a liquid air, if it is water, then it is called as steam. So the particles get separated into gaseous state. So this is how interconversion is possible. So this is the having the change of process as far as water is concerned. Ice can be converted into water, and water can be converted into gas. Now there are two processes, boiling and evaporation. Let us try to come to that. So whenever it is heated, you get a bubbles like thing coming out, and that particular temperature is called boiling point of that particular liquid. Let us try to know more about that in detailed way. Let us see. Now what is meant by this melting? In case of solid, it is called melting. The process of conversion of solid into liquid is called as melting. So when the solid is heated, particles begin to vibrate and greater speedily they move and change into solid, and the process is called melting or fusion. The temperature at which the solid melts is called melting point, and the melting point of an ice is 0 degrees Celsius or 273 Kelvin. There are two ways or two units of measuring temperature. They are scales of temperature, degree Celsius scale and Kelvin scale. Degree Celsius scale 0 degree Celsius, and this is 273 Kelvin also, at which the ice melts. Now I was asking about the question why ice, the whole ice in the Simla do not melt completely on one day. It requires some constantly absorbing of heat energy from the other matter. So there is exchange of heat energy is essential. Now suppose if you take 1 kg of ice and start heating that to convert this into a liquid, then the energy required to melt 1 kg of ice into liquid at its melting point is called latent heat of fusion. Latent means hidden. The energy that is being invested here is not used up to change the temperature, or the thermometer do not rise up until whole of the ice is being melted. So temperature doesn't change, and all the heat energy used by 1 kg of a solid to convert into its liquid at its melting point is called latent heat of fusion. Okay, so this is how it looks like, and we can find out the value of latent heat of fusion. Now boiling. What is boiling? Boiling is a condition at which the vapor pressure is equal to atmospheric pressure. Now, whenever you find bubbles coming out in a liquid after getting heated, you find that it is a boiling point of that particular liquid. So when a liquid is heated, its particles begin to move even faster, and then at a particular temperature the liquid begins to boil and changes into gas, and this temperature is called as boiling point of water. Again, similarly, there is a latent heat of vaporization. To know that, you have to take 1 kg of a liquid and go on heating it. So, when you start heating, its temperature rises. But when it starts boiling, its temperature stops, ceases. Suppose if it is water, when you start heating from 30 degrees Celsius, the temperature rises. If you keep a thermometer, you will come to know the temperature rises, and the temperature rises up to 100 degrees Celsius. When 100 degrees Celsius come at 1 atmospheric pressure, then it won't, even though you are heating, temperature doesn't change. Temperature doesn't change because the heat energy is used for conversion of the state, liquid into gaseous state. Now, what is latent heat of vaporization? It is the energy required for conversion of 1 kg of liquid into its gas at its boiling point at atmospheric pressure. So, at its boiling point is important, and this is how we define the latent heat of fusion. Remember that boiling point and latent heat of vaporization, these are telling about the interparticle force of attraction. If boiling point of a liquid is more, then it has got, the particles have got greater interparticle force of attraction. Now this is how the change of states takes place. This is cold, solid when it is cold. When the solid is heated, hot, then the particles are apart, they are having more energy. And even liquid also, the cold and the hot, there is a difference in the placement of the particles. Therefore, that changes. Now there is another process called sublimation. Sublimation is conversion of solid into gas without undergoing a conversion into liquid. So, or vice versa. A conversion of a gas into a solid without undergoing a change into a liquid state. Some substances show this property. Naphthalene, ammonium chloride, iodine, all these show such kind of property. Now, how to show? In an we can do an experiment to show this property. So, our experimental arrangement is like this: a tripod stand, a Bunsen burner, a wire gauge, china dish, and an inverted funnel, and a cotton plug. These are needed. A sublimable substance is to be taken. Here, ammonium chloride is taken. When it is heated, the solid is converted into gas, and the gas will stay on the walls of the. So, it will stay on the walls of the funnel. So, this is how sublimation can be seen. Now, what is the effect of pressure? When you apply pressure on the gases, the interparticle space reduces, and because of this, they come closer. When they come closer, they start attracting each other, and because of that, a gas is liquefied. Gas can be converted into liquid. So, it is one of the important conditions in conversion of gas into a liquid, that is applying of pressure and lowering of temperature. So, lowering of temperature reduces the thermal energy, and as liquids are having lower thermal energy, there is easily that is being formed. Now, gas, whenever applying the pressure, that becomes a liquid. Okay, liquids cannot have that much pressure. That means liquids on which we cannot apply pressure, but gases we can apply pressure. So, gas cylinder is the one container in which lot of pressure is executed to convert the gas into liquid. Now, this flowchart will tell you about how exactly all the processes that takes place. Solid can be converted into liquid. The process is called fusion. and liquid can be converted into gas. This is called vaporization. And the process of conversion of gas into solid directly is sublimation, or solid to gas is sublimation. Solid to gas is also sublimation, same name. Solid to gas and gas to solid without conversion into liquid. Now solid to liquid is fusion, liquid to solid is called solidification. Similarly, liquid to gas is vaporization, whereas gas to liquid is condensation. We can condense a gas into liquid. So these processes and its names are to be remembered. Now, evaporation is another important phenomena that occurs with the liquid. Evaporation is change of the liquid into a vapor, and this occur at the any temperature. So vaporization or evaporation can occur at any temperature. So it is normally below the temperature boiling point. This is continuously it is occurring. Evaporation is a surface phenomena, and as you increase the surface area, evaporation also increases. And as the particles at the surface are having less attraction, they show escaping tendency. Because of that, you can find evaporation. Now, what are the factors that affect evaporation? They are, the evaporation depends upon surface area and depends upon the temperature, depends upon humidity, and depend upon wind speed. They all the factors which affects the rate of evaporation. Suppose if you have a saucer, cup and a saucer, and in which of these two you can drink the tea faster. So probably your answer is saucer, because saucer is having more surface area. When you put the hot tea into the saucer, the surface area is more, therefore you can sip the tea easily, because after evaporation it will get cooled soon. And because of the evaporation there will be a cooling effect, because evaporation always occur with absorption of energy. Evaporation occurs with the absorption of energy. So when these molecules have to go freely, when they are attracting each other, the energy is required to break the bond between them to escape into the gas. Therefore, this energy is needed. Now, the evaporation is escaping of these surface molecules, and those which are having lower energy remain as liquid. Those who are having medium energy, they may be pulled back into the water, or they may escape, or if they are having high energy, they can escape through the surface of the liquid. So this is a kind of explanation of energy point of view in the evaporation. Now, evaporation causes cooling, very, very importantly. Why we feel like going to a place of water body in summer? It is probably because near the water body more will the evaporation, and there will be cooling effect. And as I told you, this evaporation is caused by absorbing the heat from the atmosphere. Therefore, it is cooling effect takes place. When you pour a petrol on your palm, this gets evaporated, and you find that palm is getting cool. It is because of process of evaporation, which is faster in case of petrol. Now, in a desert cooler, not a fan, desert cooler, there will be a pump, and along with this, there will be a water also will be there. So, when the air is moving from the desert cooler, it takes the water vapors also, and as evaporation of the water will be taking place, so cool air or cool breeze that we get. Therefore, this is how a cooling system called desert cooler works. So there is evaporation of water that takes place here. Now what is start. Okay, this is how the desert cooler works. And remember the differences between boiling and evaporation. Evaporation is a surface phenomena, whereas boiling is a bulk phenomena. Evaporation happens by absorbing energy, therefore cooling will be the effect. So this is all the content part in the matter and surroundings for the class 9. Thank you for your patient listening. Thank you.